Okay, well, so good afternoon, students. So today we are going to start the second topic of power plant economics. So yesterday we were slightly touch upon the introduction part of power plant economics. So today we are going to continue the power plant economics. So this is related to your fifth unit. Already we have completed 4 units. Okay. So the first unit we are covered the thermal power plant. Okay, and basic concepts of power plants. Okay, and the second unit we were covered about diesel engine power plant, gas turbine power plant. Okay, all those things we were covered. In the third unit we covered okay, and remaining power plants. Okay, that is MHT and some IGC power plant, IGCC. So something like that, modern power plant we were discussed. And the fourth unit we were discussed about the renewable energy sources like solar power plant, hydro power plant. Then we discussed about wind, geothermal. Likewise, we were discussing. So now we are coming to the fifth unit. So yesterday we covered the introduction of power plant economy. So why you want to study the power plant economy? What is the importance? Why the power plant economy is more important in power plant engineering or power plant? That is we were discussed yesterday, right? Now we'll come to the today agenda of the session. So in this we are going to discuss about today, okay, the operational cost. So yesterday we discussed about the two different type of cost. Okay, so anybody knows what are the two different type of cost? Yesterday we discussed. Anyone? What are the two type of cost we were discussed yesterday?
Fixed cost,
Yes, fixed cost. Very good. Sridhar, very good.
Operational
One is
cost.
fixed cost. Second one is called operational cost. Okay. Say today we are going to discuss the second cost is operational cost. So that is the today agenda of the session. So in that operation cost, okay, we are going to discuss about different type of operation cost. So when a power plant is going to operate, there are so many costs is involved. Okay, so what are the costs? Are cost of fuel, labor cost of maintenance and repair, and cost of supervision and taxes. So that is we are going to discuss today. Okay. So that is the today agenda session. So first operation cost. So what is mean by operation cost? So after implement a power plant, you are going to start a power production. Okay. So that is the main aim of the power plant. They are implementing the power plant. Mean purpose is to produce the power, and with that with lesser cost you have to produce more power. That is the main aim. Okay. So the cost of generation of power should be very minimum with using all resources. Okay, man and machine material. These are the resources. With help of that, we can produce okay, energy, electric energy. We have to produce with minimum cost. Okay. So in that, okay, we are going to discuss the operation cost. So when the power plant is running, okay, for power production, so there are so many costs are involved. That cost is comes under operation cost. In that, first cost is cost of fuel. So in thermal power station, for example, okay, and it's coal-based thermal power plant, okay, coal is the main fuel, okay. So with help of that coal only, we are producing the steam, okay. So with help of combustion process, water is converted into steam. So without coal, we can't produce the steam. Without steam, we cannot generate the power. So this is the background, okay. So if a thermal power plant is operated in without fuel, you can plays a very important vital role. Okay. So the cost of fuel play very important vital role. So that produce okay high operation cost. So that's why we are discuss the cost of fuel is a major aspect. Okay. In a thermal power station, fuel is the heaviest item of operating cost. The selection of fuel and maximum economy in it use are therefore very important consideration in a thermal power plant design. So while designing a power plant, we have to think, okay, what type of fuel we are using, okay, how much power we are producing with help of the power plant, okay. So with help of the power plant, we are producing it, how much energy we can generate, and what will be the cost of tariff, okay. So if we supply to some agents, what will be the tariff, and what will be the fuel cost, and how we can tackle that, okay, how we can make a profit. So that everything is very, very important. So while usage of fuel, okay, you have to think all the aspects, okay. So that's why we are going to study the cost of fuel on a separate manner, okay. So it is desirable to achieve the highest thermal efficiency for the plant so that fuel charges are reduced. So any few type of power plant, mostly fuel may be used. Okay, all the power plant you can see have some fuels is used. For example, if it is a gas turbine power plant, okay, you have to supply a gas. Okay, that is natural gas normally used. If it is a diesel power plant, uh, what type of power plant means that is conventional power. I'm talking about only conventional power plant. Okay, so if it is a diesel power plant, mean okay, we have to supply the fuel. That is diesel fuel we have to supply. So in all type of conventional power plants, okay, we have to supply the fuel. So for that fuel, you want to produce more energy. Okay, that means we have to achieve highest thermal efficiency. So the thermal efficiency, if it is increased, means the steam production is also increased. That means thermal efficiency is increased, means okay, our power plant energy producing also increase. That is the meaning behind on it. Okay. So the cost of fuel include not only its price at the site of purchase, but its transportation and handling costs also. That is why, okay, I told yesterday, cost of fuel is we have to take care. Okay, because okay, we are to transport your fuel. Okay, from one point to one our power plant. Okay, normally I told you yesterday, if you want to start a power plant in our area means okay, lignite is not available. Okay, so somewhat coal if you want to buy mean okay, then you have to identify the coal source area. Then you have to okay handle the coal. Okay, from that point to okay you have to use help of transportation. Okay, then we have to uh, shift. Okay, so what I'm trying to say is, so the cost of fuel not only we have to take it. Okay, while calculate the cost of fuel, we have to also add the transportation and handling cost. Okay, that is very important. So handling means I already told now. So if we are use the fuel means we have to use the fuel according to the power plant requirement. So if it is a coal-based thermal power plant, a pulverized coal is used. So if you receive the coal from coal mine, that will be a different size. Then you have to treat the coal and then you have to go use in the dryer. Then you have to remove the moisture. Then you have to use the coal handling devices. Then you have to use coal sizers. So all those things is required. Okay, for prepare the coal. Okay, before feed it to the combustion chamber. So that everything the cost will place. Okay, so all the cost you have to account. Okay, while calculating the fuel cost. So that is also very important. In a hydropower plant, the absence of fuel factor in the cost is responsible of lowering operating costs. So if we see a hydropower plant, okay, the fuel is not required. So in a hydropower plant, the main source is water. So water is freely available in that area. That means there is no cost of fuel. Okay, but the factor in the cost is responsible for lowering operating cost. So sometimes this kind of power plant, okay, the cost of fuel is very low, but the operating cost also it will take much, okay, and sometimes it will also goes lower, okay. So the cost is responsible for lowering the operating cost, okay. And next one is plant heat rate can be improved by use of better quality of fuel or by employing better thermodynamic condition in a power plant design. So I already told now. So the cost of fuel is okay depends upon various factors. And that one factor is the quality of the fuel. So if the quality of the fuel is not good, means definitely you are used to more amount. Okay, so more amount you are more amount of fuel you can utilize for producing the energy. Okay, that means okay the cost of fuel is increased. So unit price of fuel is increased for energy for the for energy producing is higher mean okay that will affect the entire power plant operation. Okay, so you have to think, okay, while design a power plant, okay, on various, okay, factors like unit price of fuel, amount of energy produced, efficiency of the plant, everything you have to consider, okay, uh, you purchase the fuel. Okay, so how much, what is the quality of fuel, how much of fuel we have to buy, okay, what will be the energy, with help of that, what, how much energy we can produce, okay, what will be the cost, okay, what is our efficiency of the plant. Then uh, how the thermodynamic conditions or heating condition can be improved. So every factor we have to consider while uh, purchase of fuel. So that all comes under cost of fuel. So if you buy a fuel, okay, simply you are buy a fuel, it's not an good work. Okay, you have to think in all the aspects. Then only we can minimize the cost of fuel. Okay, that will leads to, okay, reduce our operational cost. Okay, next, labor cost. So there are so many peoples are working in the power plant. So if the peoples are working, definitely we have to pay. Okay, and also some insurance and everything we have to provide insurance facility, insurance to the people, and some facilities we have to create for the working people. So everything is comes under a cost. Okay, that cost is come called as labor cost. For a plant operation, labor cost is another of operating cost. Maximum labor is needed in a thermal power plant using coal as a fuel. Hydraulic, because if you use a coal, you mean we have to use before the combustion, we have to treat the coal, no? So for the purpose, so many peoples are required for preparation of coal. So the cost of labor is increasing in a thermal power plant. Okay, in a hydraulic power plant or a diesel power plant, equal capacity required less number of persons. So with the use of or minimum number of peoples, we can develop the power. But comparatively, okay, with thermal power station, okay, it is very very minimum, so we can reduce the labor cost. But whereas in a coal or thermal based power plant, okay, labor is more, that's then ultimately cost of the labor is increased. In case of automatic power station, the cost of labor is reduced in great extent. However, labor cost cannot be completely eliminated even with fully automatic station, as they will require some manpower for periodic inspection. So, based upon the modern technologies, okay, we are implement so many automatic systems. Okay, so every monitoring system is now it is automated. So automatically mans are eliminated. So even though, okay, some manpowers are eliminated, some periodic inspection purpose mans are required. That is, without manpower we cannot run the power plant in an effective manner. So only we can eliminate unnecessary people. Okay, not unnecessary, we can say, okay, if we implement some technical or technological area, okay, we can implement. Okay, so wherever the technological is required, that area we have to identify. Then we have to automate that area. Then we can eliminate the people. Then only we can run the power plant in an effective manner. If simply we remove the manpowers, mean that will affect the power plant operation. So first we have to identify where, okay, people's not required. So when we can implement or how we can implement, that will be decided first. Then after implementation we have to rectify, okay, if any problem is arise, then only when we will think of manpower reduction. So based upon that we can reduce the cost. So these are the aspects comes under labor cost. Okay, then cost of maintenance and repair. So that is also you may know very well. So there are so many instrument and equipments are used in plant. So if you want to repair, means, okay, some maintenance is required. Okay, sometime may breakdown may be happened. Okay, so you have to do some breakdown maintenance. So So you have to buy some spare parts or something replacement. You have to done some overhauling. You have to done for greasing, cleaning purpose, overhauling the equipment, and some maintenance work. So now different type of maintenance work is goes. So breakdown maintenance, preventive maintenance. Okay. So this type of maintenance needs some cost. Okay. So all this activity, related with one related with cost. That cost are comes under cost of maintenance and repair. And next one is cost of source. Yesterday I told so greases, cotton waste, some small tools, chemical paints, some other things are should be used in the power plant as a consumable part. Okay, that will be stored in the power plant. Okay, inside the power plant. So that's need at cost. Okay, if you want to store means you have to purchase and we have to store. So for that purpose, we need some money. Okay, that cost is comes under cost of source and supervision. Yesterday also we discussed uh, uh, for better maintenance. Okay, for if you want to cut down the if you want to do some maintenance operation or you want to increase the power plant production means you have to do a continuous supervision. So supervising staffs include station superintendent, chief engineer, chemist, engineer, supervisor, store in charges, purchase officer. So these all are called supervision person. So without these persons, we cannot run an effective manner. Again, on thermal station, particularly coal field, have a greater instance of this task than an hydroelectric power station. So every area, for maintenance, every area for power production, and all the areas engineers are required. So if you if you are not supervised properly, mean definitely plant maybe breakdown maybe comes in the plant, severe breakdown maybe occur. Okay, and regularly it may have happen, and your power production capacity may be affected. Okay, so people's maybe a lethargic activity maybe arise. So everything should be controlled when we have to supervise. So that's why peoples are recruited and placed as a supervisors. Okay, so with the help of supervision, we can improve the power plant production. So definitely we have to pay for the supervising people like engineers and supervisors, storage as a purchase officer, everybody. Uh, they get salary. Okay, so definitely it will comes under a cost. That cost is comes under supervision cost. And yesterday we touched upon taxes. No? Taxes. What are the type of taxes? There are so many taxes we, we have spent for production of power plant, for production of power. Like if you want to buy something means we have to use sales tax. Okay, and also if you want to give some production, if you are producing a power mean, then you have to supply to some agency mean. Okay, based upon the government taxes policy, we have to say some GST tax, all those things are comes under the bill. Okay, so everything is comes under around one cost, that is all related to operational cost. Okay, so la cost like as income tax, sales tax, social security of employee security, recently added goods and service tax, all the government taxes are comes under the account of operational cost. So this is about a different type of operational cost. So today we discuss about what is mean by operation cost, how it is important, and what are the different type of operation cost. That is cost of fuel, labor cost, cost of maintenance and repair, cost of supervision and taxes. So these all are related to operation cost. Okay, now please behold, I will show one video related to a power plant economy. For example, if you take a solar power plant, how the economy, a cost of production can be controlled. Okay, how we can run a power plant, solar power plant in an effective manner. Okay, so I will show one video, you will understand better. Okay, please be in the line. I will just show.
This video is going to show you the financials for a 50 kilowatt commercial solar system. If you're thinking of solar, this is the essence of it. This is a demonstration in the form of a video of our financial modelling process. It will show you some actual numbers about what a solar power system costs and how much it will benefit you. A lot of people have misconceptions about solar power, so before I jump into the financial model, here are some points clarified. Solar is not your only source of power. You still keep the grid and therefore have a stable power supply. You can't eliminate your bill. You still have costs on your power bill which don't necessarily vary according to your electricity consumption. For example, there are fixed daily rates and charges based on peak demand called kVA, amongst others. In addition, when the sun isn't shining, you pay for the power that you use. Solar isn't a switched system, so it's not as if your business runs on solar power, then that switches off and it runs on the grid again. I call this the Toyota Prius view of the world. In reality, it is more of a blending of sources, grid power and solar power. Your solar panels are always producing power as long as there is light. If the sun isn't shining, it doesn't provide power, and you will then run off grid power. When it's cloudy, it still provides some power, and in all cases, it just blends with your existing grid power supply, so you always have a full supply of clean electricity. That system is passive. You don't need to do anything. A steel fabricator once said to me, "Solar won't work for us, we pull an amazing amount of power." Solar is not trying to supply all of that power, just diminish your demand from the grid. Okay, here's an example and those numbers. Let's say you're looking at a 50 kilowatt system just for the sake of an example. Let's say you have a metal roof and we put the panels on tilt frames and we use good quality components such as a top brand of solar panel and a good German inverter and a quality monitoring system. This system might consist of 200 panels and take up approximately 400 square meters of roof space if the system is installed flat on roof. So here are those actual numbers. The full cost of that system will be around $110,000 excluding GST. You then get a point of sale rebate for the STCs, which are created and are worth around $35,000. So it becomes an out-of-pocket cost of around $75,000. Underlying our model is an assumption about how much power is produced. We know how much power any given system size produces because we can observe it by monitoring, and the Clean Energy Council has published some average output data for different regions. This output will vary day by day, season by season, but will be correct year by year. Based on the Clean Energy Council guidelines for Sydney, a 50 kilowatt system will produce around 195 kilowatt hours per day. When we create a financial model, we're fairly conservative about saying what this output is. We also reduce this around the number of work days that your business has, because it is only power that is used as it is produced that matters, and you don't get paid for exported power in most commercial scenarios. So on a 50 kilowatt system, the output is around 195 kilowatt hours a day. We analyze what you pay for power, and this is not 100% intuitive from your power bill. We look at the variable costs, which are made up from three categories of your bill: the main rate, the network charges, then the ancillary charges. In many businesses, this will all add up to be between 11 and 25 cents per kilowatt hour. This is the value of power to you, as you are substituting self-generated solar power for grid power. In our model, we run an analysis where we say power will rise by a certain percent per year. So, here's an example of the savings. Year 1, Year 2, Year 3, and so on. We then map this out compared to the initial investment, and we get a graph that shows this payback. Let's say you borrowed money to put the system on. Using the cost of finance, we will also model that, and this will have two impacts. First, it makes it easier to buy, sometimes with no initial capital outlay. Second, it extends the payback by a year or so due to interest payments. When we create the financial model, the purpose is as a prediction of how solar will perform for you. So we need to take into account a range of factors. Here are some of the things that we cover. We feel this makes it pretty accurate. And what it shows you is that solar will deliver for you. So to work out how solar will work for you, we need to start with a conversation about four things: your roof space, your power usage, the rate you pay for power, and your timeline. If a payback of 4 to 7 years will be suitable for you, great, let's talk. We can put together a financial model in the form of a solar business case, just for you. As positive as we are about solar, there are a couple of instances where we think it won't make sense. Here's 3 examples. A lack of clear roof space can make things difficult. Some office buildings could put solar on, but it may be relatively small compared to their usage. A lack of usage can limit solar's usefulness, as you need to be consuming the power that it generates to make it economically viable. Even if you have a large roof, but if you don't use a lot of power, then solar may not suit. Take as an example a storage warehouse. It may have a great roof, but use just a few lights and little else, so the power produced would be exported for little or no benefit. A third reason that solar might not suit is that you don't have the right time frame. You might be in a short-term lease or thinking of moving. If you can't see yourself being in the premises for at least 5 years or so, the decision becomes clouded. Some industries are well suited for solar. For example, manufacturing, food processing, many primary industries, golf clubs, RSLs, refrigeration, mechanical workshops, engineering and fabrication, some warehousing, offices, and anywhere that has a regular power load. So if you have a roof space, high power usage, and a view of the world that extends past 5 years, solar will most likely be great for you. The returns on investment in commercial solar are very attractive and can often exceed 20% per year. The returns are also highly predictable, which makes the investment low risk. All in all, a pretty compelling case, we think. The figures here for a 50 kilowatt system can be extrapolated for a 100 kilowatt system, as long as your roof space and power consumption allow for that. The return on investment is the same, just the investment size changes. Businesses. Financially.
So that's all from now. Okay, so these are the different type of tasks, okay, involved in the solar power plant. Right. So you have any doubt? Now you can ask.
No doubt, sir.
Okay, thank you so much, Deep.
Yes, sir. Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.